welcome to the next lecture of PDSA, in which we are going to go for the last 3 data types in Python. The last 3 data types in the Pythons are bytes, byte array and memory view. These all three data types very close to the machine language, or you can say it is a very favorable to the low language. So, that is why this data type is considered as binary data type. In the binary data type, you can see it is a sequence of ones and zeros. So, ones and zeros are referring to the binary data type, and these 3 data types are very close to access to machine language. So, the very first data type is bytes. So, what do you mean by bytes? Bytes is generally a collection of bytes. Generally, its byte is equivalent to 8 bits, or you can say 4 nibbles. So, 1 byte is equal to 1 nibble or 4 bits, and this bytes is a collection of byte. It is very similar to the Unicode. You can see we have seen this ASCII or UTF-8 formats. These are represented as the Unicode formats. So, whatever the characters we have in these Unicodes are almost identical to this byte data type. Now, in this the bytes objects are generated which are totally machine readable form, or you can say in low language form. That means, it is very easy for the machines to read and write, but it is difficult for the humans. The next thing is, since it is directly machine readable format, so it can be directly stored on the disk, that means, or directly stored on the memory space. The next important property is it is totally immutable. The immutable means that whatever the information you have inside the variable, the elements of that value or the information is totally unchanged. The next thing is that when we are dealing with the byte, and if in that the string data type is taken to convert into the bytes, the process of converting the string into the byte is represented as encoded. That means, we have this str as a string data type, and the another side we have this bytes. So, here you can see that if we are putting the information from the string to bytes, it is known as encoded. That means, we are encoding the string information into the bytes. In the other languages, this string is referred as collection of characters, but it is totally inappropriate in Python, but still we are using this character because it makes easy sense in this byte data type. So, when we are converting the bytes into the string again, it is known as we are decoding the bytes to the string, and this process is known as decoded. That means, bytes are decoded to the string. It is only possible in the string data type. That means, it is totally exception to the string data type, that whatever the information it will hold, it will directly encode to the byte, and from the byte it is directly decoded into the string. Now, we are going to look at the example of bytes data type. Now, here you can see that we have the variable mybyt, and in that we are putting a string good morning, because it is inside this quotation mark, but you can see that the very first character or the very first point in the string is this is small b, and it is lying outside this quotation mark. This small b represents that it is not a string data type, but it is the byte data type. This small b or b are either in small, caps, or the combination of the lower and upper cases is referring to the byte data type. That means, if we are going to put the information as b, br, then the type related to these two variables will be the byte data type. Now, look at the program output of this one, and you can understand it very easily, that here the my by byt variable is again the same, but here you can see that the class belongs to the byte. That means, this data type is byte data type, and we have again taken the help of type function. So, this B stands for byte. Similarly, this BR also stands for byte, because we are getting the output as bytes. Similarly, this capital BR is again making the combination as a class bytes. That means, B, BR, B capital R, capital small r, capital BR. These all things are referred to one thing known as bytes. So, here you can see that whenever this B is available at the starting of the string, that means it directly represents that it is a byte data type. Next thing, now look at the syntax of the byte constructor. Now, whenever you want to construct the byte data, you are going to take the help of this byte function, or you can say byte constructor, in which the three informations can be taken as input. The one is source, second is encoding, third one is error. The very first thing, the source is whatever you are going to put the content in the output to get the byte. That means, whenever you are going to initialize something, it can be string, it can be integer, it can be byte, or it can be iterables. Now, in the upcoming lectures, I am going to debate on this thing, that what do you mean by the iterable. So, for the now, just take this word as it is. The next thing is, we are going for the encoding. Now, encoding is only applicable to the string. Here you can see the encoding is only for the string. The last thing is the errors. Now, generally the errors are taken as the restrictions whenever the encoding process fails for the string. You can see that whenever the string encoding process fails, then this error will help out to short it out. Let us say if the error is taken as a string, that means whatever the conversation we are putting for the string, if it is not encoding into the bytes, it will directly raise Unicode decode error. Similarly, if you are going to put the error as ignore, that means it will directly ignore the portion whatever that portion is uncodable. The last one is the replace. These three are the options available inside the error. There are some more options available for this error parameters. We are just limiting ourselves to these three information of the errors. So, in the last one you can see the replace one, which can directly replace something with the unencoded Unicode. Now, look at the example. Now, here what we are looking at, that we are trying to convert the byte for this good morning using the format ASCII. The ASCII is a Unicode format in which the number of characters are given some specific numbers, or you can say values. So, the characters are linked with some values under the heading of ASCII. There is other formats like UTF-8, UTF-16, UTF-32. So, here what we are doing is we are converting this string into the bytes. Since this is the string, that means now we need the encoder too. So, we are processing the encoder as ASCII. Similarly, you can confirm the output of the program by using the type function. The next thing is we are converting the bytes, but we have taken not as a string, but it is a byte itself. So, it has a byte information of good evening, and again we are going for the type. Along with that, now we have taken the integer data type. So, now question arises, the what is the output for this integer? The answer is that it will create the array. It will create the array of size 12, because the 12 is the number. That means, whenever you are going to put the integer as a number inside the byte, it will directly create the array of that much size. Again the type will be the bytes, and the last one is if you are putting the iterable. Now, here you can see in the iterable format the data type is list. Now, look at the output of this program, and here we are going to confirm it that what is happening here is when you are putting the string, you will get this B in front of this good morning, it directly represents the byte. Similarly, the byte, when the byte is converted into the byte, again the format remains the byte, but what about this integer 12? This is 12 in numbers. That means it is the array of the size 12 with the default value 0. Since in the previous slide we have confirmed that this bytes hold the property of immutable, that means you cannot change the values of these elements. The next thing is, now here the iterable object is the list, and in that the input is 1, 2, 3, 5, 25, and here you can see the output as byte x01, x02, x03, x05, x19. So, when you look at this carefully, it is generally a hexadecimal representation of the iterable object. The next thing is we are going to perform the some simple operation with the bytes data type, and we are going to confirm whether they are applicable or not. We have taken the two bytes, one is good evening, the second one is good morning, both under the headings of respective variables my underscore 1 and my underscore 2. The next thing is, now we are performing the addition of two bytes. Is it possible or not? Yes, it is possible. The next thing is we are looking at the 0 index of my underscore 1. The output for this must be the capital G, and similarly for the my underscore it is -1, that means this exclamatory mark. The last thing is, it is in the red, that we are trying to update the value related to the 0 index number of my underscore variable with the 65, but it is not possible because in bytes the property holds as immutable. Now, look at the output of this program. Here you can see now it is sticking together just like the string. That means this process is concatenation. So, the concatenation is happening under the bytes by using this plus operator, just similar to the str. But what is happening here when we are accessing the 0 and -1 of my underscore 1 and 2, you can see you are getting 7133. Now, these are almost similar to the ASCII codes. The capital G has the ASCII value 71, similarly the exclamatory mark has a value of 33. But when we are trying to access this value and updating this one, it is not possible because of type error. It directly says that byte objects does not support the item assignments. It directly confirms that these are immutable. Next, see how we are going to encode the string into the bytes. Here we have the two strings and we are taking the help of the encode method. In the encode method, you need to put the information of the encoding format. Here the encoding format is ASCII. So, you can see in the method the syntax is the variable followed by, this is the variable followed by the method name followed by the inputs. So, you can see that the dictionary, that the string is encoded into the bytes. Similarly, the reverse process of the encode is the decode, but before that, now look at the output of the encoding method. Now, here you can see the str1 is good morning, the second one is 1 2 3 4 5, and the respective output is with this B in the prefix. This directly confirms that yes, the strings are encoded into the bytes. Similarly, the reverse process of encoding is decoding. That means, if you have the bytes, you can reverse this process by using the decode. Again the format is the same, that is the variable, whatever the variable we are going to decode, that variable followed by the method name followed by the inputs. So, here now this bytes are converted into the str. Now, look at the output of this program, and here we have confirmed it, yes. Now, the string, these data types are converted in the string, that means the bytes are converted to the string data type with the help of decode method. The next thing is, now my underscore 1, my underscore 1, and we are accessing the values of 0, 1, 2, 3, 4, and here we have already know that this cannot be changed because of immutable property. But what is the output of this program? This output of this program is phi 0, because when we are converting the byte from int, this is converted into the array. So, this number is 5, that means this array holds a size 1, 2, 3, 4, 5, that means this is 5. This integer is taken as a number for the size of the array with the default value is 1, and after that you cannot change it because it is immutable. The next data type is byte array. In this byte array, here you can see that the very first thing is the object related to the byte array, or you can say the return of this byte array is a byte array object. The array of this given byte is totally mutable, irrespective of the byte data type, that is immutable, it is totally the mutable sequence. The syntax is almost similar to the byte, that is source, encoding, error, and the same principle is applied only for the str. That means, the encoding is only specially for the string, the errors are especially for the string encoding, where the encoding of the string into the bytes fails. So, again we are just limiting ourselves out to these three parameters of errors, that is strict, ignore and replace. So, here again the process is very similar to the bytes data type, but in this byte array whatever the array is formed, that is totally mutable. That means, the elements related to this array set is mutable. Similarly, the my byt is a variable in which we are going to perform the casting of, here you can see it is a string, the casting of the string into the byte array. Now, byte array is going to be casted with the help of byte array constructor. So, in this byte array followed by the string, now for the string the encoding must be there. So, this is our encoded format. By default the information must be in ASCII, but you can change it to UTF-8. So, that means, the good morning can be converted by using the ASCII or UTF-8 or the other formats for the byte array. The next is we are converting a byte into the byte array. The next is, now we are converting this number 12 into the byte array. Now, again it is going to create a array, because the byte array will create the array, but of size 12. But what is different for the byte array with respect to the bytes is that this byte array is mutable. That means, that every element of this array can be changed. The last one is the iterable object. Now, in iterable objects, again this information is stored in the form of array, but again it is mutable. Now, look at the output of this byte array. In the byte array, here you can see that the good morning, here it is str, but in the output here you can see the B is in front of this good morning. It means that it is must be in the bytes. But with the help of this type function we have confirmed that this is a byte array. Now, similarly the good morning is changed into the byte array. That means right now this my byt which holds the good evening as byte array is mutable. Previously, before casting the good evening into the byte array, the good evening is not mutable because it is a byte. The next is the number 12, that means the integer data type. When we are putting the integer, again the array is formed with the 12 elements and all the elements as a default information of 0, but you can update this information, that is my byt, because these are mutable. The next thing here you can see, now we have again changed this iterable object into the byte array, and here it is again into the format of hexadecimal. So, in this you can see that the byte array converts the iterable objects into the hexadecimal format, in which the numbers are divided by 16. The next thing is, now we are going to perform the addition operation, whether it is applicable to byte arrays or not. Yes, it is going to be applicable to the byte arrays. Along with that, we are going to see whether the information can be updated or not. If it is updated, that means the property of mutable holds true for the byte array. Now, here you can see that plus is used for the joining of my 1 and my 2, and similarly you can access these elements with their respective index number, because the byte array also holds the indexing principle, in which you can access the elements by using the index number. Now, this process almost remind you of the subscription process. So, in subscription process, the variable followed in the square bracket of a number, that number represents the index value of the respective data set. So, in the output you can confirm that this good morning is added with a good evening. Along with that, you can access the information, that is you can use the indexing principle with the subscription principle, but here is the next difference, and this difference is that this is mutable. Now, look at this one. Now, here it is good morning, but instead it is writing old morning. That means we have changed the value of the 0 with 65. The 65 represents capital A. Similarly, here it is also represents capital A. That means 2 of 7, that is 4, 5, 6, 7. That is V has been replaced. Yes, sorry, E has been replaced with A. So, here you can see the changes can be made to the elements, and due to this byte array is mutable with respect to bytes. The last data type in the Python is memory view. Now, in the memory view you can see the memory view, the objects returned is memory view. Before moving towards the memory view, you should be familiar with buffer protocol. The buffer means the extra space for processing, or you can say it is like a temporary space given to the program to put some things temporary. So, when we are accessing this buffer protocol, we are generally exposing ourselves, that is we are exposing the internal data without intermediate copies. It is just like that. Right now we are looking at the original copy of the data set with the buffer protocol, and under the normal codes you cannot see it, because it is very difficult to see the original data sets of a given program. But under the buffer protocol it is possible, and with the help of this memory view you can get the safe passage for the accessing of buffer protocol. So, if you are dealing with the original data set That means, whatever the actions or whatever the changes you are going to make on that object, it will directly reflect on the original one. That means, there is no need of creating an copy, instead you can do the work on original one. But again it is a double edged sword, that means this is the advantage, but the disadvantage is we can lose the data forever. So, using the buffer protocol, that with the help of memory view you can modify the data without copying it. Now, the advantage is it requires the less memory and the execution speed increases, but the risk is if you are not expert in that data type, you should not better touch that data type, because a little change in that one deals with the loss of data or original information. Now, look at the syntax for the memory view. Here you can see this is the memory object and it requires byte. That means, whenever you are going for a memory view data type, you should have the conversion into the byte or byte objects. Now, look at the example how we are going to access the memory views of respective bytes. Let us say we are looking at the 43, this 43 is an integer, but we are converting into the byte and we are storing this byte into the my int. Similarly, you can see this river Tapi, which is again directly converted into the byte. The next one is the LST, that is again we are converting the iterable object into the byte array, and the last one again we are converting this dictionary data type into the byte array. That means, all these 4 data types or these 4 variables are in byte object. So, the primary requirement of the memory view constructor is byte object, and we have fulfilled in this first 4 steps. The next is, now we are going for the memory view creation with the respective variables with MV1, MV2, MV3 and MV4. Now, here you can see that we have successfully created the memory view of the respective 4 variables. Now, here you can see that the memory address of every information is reflected. Now, that means you are able to reach that address directly with the help of memory view. Let us put some operations under the memory view. Now, here what we are doing is we are trying to access the elements one by one. You can see the elements MV1, the MV1 is a byte of 43, it is an array. So, in array the 0 is available, yes it is. Similarly, the string the 1 character is also available. Similarly, in the byte array you hold the position of the second index number, and in the last one there is only 3 position, that is 0, 1 and 2. So, we are going to access the elements by using the subscription principle, and we are able to do that. Now, look at this one, this performs the array with default value 0, since it is a byte it is totally immutable and its value is 0. Similarly, here you can see that the next value is 105 and we are asking for I. So, for the I the value is, sorry, it is not for I, it is for it is for I. So, for I the value is 105. Similarly, you can see in the LST, that is the list, this 2 is reflecting the 3 element of this one, and the last in my DT, here you can see that yes it is reflecting the key element, not yes. So, it is now reflecting the key element of dictionary. Now, can we see that they are mutable or not by using this operation, and with this we are able to see that these things is mutable. That means, the byte array in the memory views are mutable, but there is one hidden characteristics of mutability. That is, if the byte array is taken as a byte object, that means the memory view will be mutable. If the bytes are taken as a byte object, then that is totally immutable. Since it is a byte array, it is already mutable. That means, this is also mutable. Now, here going to see that there are changes or not. You can see that the river R is there, in the output it is A. So, with these changes you can see the reflection in this statement. Now, it is AIVER 1 TAPD, which is reflection of river Tapi with the modification of this one. Along with that, you can also confirm that this my LST is also reflecting this changes. That means, whatever changes you have made in the memory view, it is directly reflected to the original one. But what about if the bytes are taken as immutable? When the bytes are taken as immutable, it directly shows that they are also immutable. Now, look at the program. Yes, cannot modify, because it is only the read only memory. You can only read it, but you cannot write it. So, with this I have finished my lecture. So, in this lecture we have seen the last three data types, that is byte, byte array and the memory view. And in the memory view, one point must be very important, that is the mutability factor depends upon the byte object. If the byte object is mutable, that means the memory view is also mutable, otherwise it is not. With this I will stop my lecture here.